Welcome to the VG Tutorials. In this video, I will show you how to speed up inspection processes by automating the workflow of a porosity analysis in VG Studio Max. The automation process I'll show in this video is ideal for line CT systems and foundries, where series accompanying random checks as part of quality assurance, and repeated inspections of a larger number of identical castings. As part of initial sampling, investigations into process capabilities, requalifications, or customer complaints are among the many time-consuming everyday tasks. With the automation tool of VG Studio Max, all you have to do is define the workflow once and create an inspection plan, a so-called job that you can then run on as many data sets as you like. And this is what we're going to do in this video. On the basis of the porosity inspection workflow we defined in our first tutorial, we'll define the macros we need to record. In VG Studio Max, we will use the automation tool to record the macros one after the other. Once we've recorded all the macros, we'll combine them to a job. And with our job created, we can start our inspection with a few clicks. We select the job and the data sets we want to inspect. Create a directory for our results. And that's it. The software will do the rest. Okay, now that we've seen what we're up to, I'd say we get started. As a first step, let's define the macros we need to record. This is our porosity analysis workflow from the first tutorial. I will record a macro for the surface determination, one for the CAD import, one for the alignment of the volume object to the CAD model, and finally, a macro for the import of the evaluation template. Let's focus a moment on the evaluation template. The porosity analysis itself cannot be recorded directly with a macro. Instead, I have to set up the analysis once, including the test regions, the porosity keys, and the visualization settings. Then I can save all this information in what we call an evaluation template. When recording the macros, all I have to do is import the evaluation template. For this tutorial, I'll use the evaluation template that I created at the end of our first tutorial. Okay, looks like I have defined all the macros, so let's record them. I'll open VG Studio Max and, on the Welcome page, select the Porosity tab. This way, I have all controls for porosity analysis conveniently in one place. To load the VGL file into the scene, I'll select File Open and browse for the VGL file. The volume data will be loaded into the scene. To record our macros, I'll need the automation tool. You'll find the tool in the tool dock on the right-hand side of the screen. If it is not activated by default, you can open it via Window Tools. Now, to start the recording, I'll click the Record Macro button here. Everything I do from now on will be included in the macro. Our first macro will include the surface determination. In the scene tree, I'll select Volume 1. On the Home tab, I'll select Surface Determination Advanced Classic. In this dialog, I can now specify the settings for the surface determination. What is important is that you set Material Definition to Automatic to make sure that the surface will be determined for each data set individually. Then I'll set the filters for voids and particles. And I'll click Finish to start the calculation. Once the calculation has been completed, I can stop the recording. Back in the automation tool, I'll click the Stop Recording button. Now the only thing that's left to do is give the macro a name that helps me to easily identify it. So let's do that. I'll click the Rename button here and name the first macro P203 surface determination. And I'll add PB for pump bracket. Then I'll click Accept. And here it is, my first macro, which includes the surface determination. Now, the second and third macro will include the import of the CAD model and the alignment of the volume to the CAD model. Remember, aligning the volume to the CAD model is necessary because the test regions we'll be working with were created on the CAD model. To make sure they fit perfectly on the volume, I need to align the volume to the CAD model. Let's start with the import of the CAD model. In the Automation tool, I'll start the recording of the second macro. I'll select Quick Import and browse for the CAD file. I'll select a medium mesh accuracy and complete the import. As you can see, the CAD model has been imported. I'll stop the recording. And I'll rename the macro P203 CAD import PB. Done. Off we go to the third macro, the alignment of the volume object to the CAD model. I'll start the recording. In the scene tree, I'll select Volume 1. Then I'll perform the alignment. On the Home tab, I'll select Alignment Best Fit Alignment. I'll check that the volume object is the object to be aligned, and the CAD model is the reference object. Then I'll click Finish to start the calculation. In the 3D window, I can see that the alignment has been successful. I'll make the CAD model invisible. Then I'll stop the recording and rename the macro P203 alignment PB. Done. Okay, there is one macro left, the import of the evaluation template. As I mentioned before, the evaluation template includes the test regions, the porosity analysis, the porosity keys, and the visualization settings. In the Automation tool, I'll click Record Macro. In the scene tree, I'll right-click Volume 1, select Import Evaluations, and browse for the evaluation template. I confirm the Import Evaluation Template dialog with OK. And, as you can see, the import of the evaluation template has been successful. I'll stop the recording and rename the macro P203 analysis, PB. Okay, I have defined and recorded all the macros I need in order to automate my porosity analysis. Out of these macros, I can now create the job, that is, the inspection plan. To do so, I'll open the Advanced mode of the Automation tool. The recorded macros are listed on the left-hand side of the dialog. To create a job, I'll select all macros and click Create Job from Macros. Then I'll click Create Job from Macros. A wizard will open to help me make the necessary settings. I'll give the job file a name. In the next dialog, I'll click Save to save the job output. And that's basically all I have to do in the wizard. I'll click myself through until I arrive at the end, and then I'll click Finish. As you can see, a job has been created that I can now save in a path of my choice. So let's do that. I'll click the Save button and save the job. We're done here, so let's close the Advanced mode of the Automation tool. In the Overview dialog of the Automation tool, I can see the job here. And in the Job Details field, I can see all macros included in the job. Okay, I have created my job. Now let's see how I can apply the job. First of all, let's clear the scene. I'll select File, New. I don't want to save the current project, so I'll select No here. The scene is empty and ready to go. Now, we're almost there. There is one tiny setting I still need to specify before I can run the job on my datasets. On the Settings tab of the Automation tool, I need to make sure that Run on Files is selected as Job Playback mode. That's the case here. Perfect. I'll go back to the Overview tab. I'll make sure my job is selected here. Then I'll click Run Job. As a next step, I'll select all files I want to include in the inspection. For this video tutorial, I have prepared 2 datasets. But of course, you can select here as many datasets as you like. I'll select the files and click Open. Next, I need a directory for my results, so let's create one. If you have selected more than one VGL file, as I have here, you will be asked if you want to save the job output for each VGL project in subfolders. I'd like that, so I'll click Yes. The job will run on all selected VGL files. In the 3D window, you can see the results of the last inspected casting. And the output projects will be saved in the specified directory. And that's it. In this video, I showed you how you can speed up CT inspection processes in foundries by automating your porosity analysis workflow. On the basis of a once-defined porosity analysis workflow, I created a job that I can run on as many data sets as I like. The results are saved conveniently in subfolders. And the job file contains all related files and data, which allows you to easily share it with colleagues and customers for its use with other at-line or in-line CT systems using VG Studio Max. This was the second of our 3 tutorials on P203 porosity analysis in VG Studio Max. If you want to dive deeper into the topic, make sure to check out these tutorials. In our tutorial P203, Implementing a Porosity Analysis Workflow, you learn step-by-step how to set up a workflow for a porosity analysis in VG Studio Max. And with our video tutorial, P203, Creating Test Regions Using CAD Data, I'll show you how to create test regions to perform porosity inspection on specific regions of a casting. And, of course, you can check out the PDF version of this video and try it out on your own. I hope you enjoyed this video. You'll find a list of all our tutorials on our documentation landing page via Help, Show Tutorials. Plus, make sure to register on Nexus and make it your go-to place for sharpening your expertise. Get access to this video and other information material to get the best out of our software. And visit the VG community to exchange ideas, ask questions, and discuss topics with other users and our Hexagon experts. And stay up to date on the latest news and developments. Register now, a world of insight awaits. Thanks for watching, and see you soon on Nexus.